Hi guys, I'd like to begin today with taking a look at the second part of the Batman problem we did the other day in class. I want to take a look in particular about what happens when Batman lands in the Batmobile. So if you recall, we went ahead and solved this problem last time for how far away the Batmobile should be parked from the edge of the building. And we had written our variables out in both the X and the Y direction. We had solved for the amount of time it took him to get to the ground, and then we solved for how far he will travel horizontally from the building. So we have all of these quantities. And the question I want to consider here at the end is how fast is he going when he lands in the Batmobile? Now the problem with that is we have two different answers. We have an x velocity and we have a y velocity, which we don't actually know in this case. Now looking at our vertical knowns, we can solve for that y velocity. Looking at the other knowns that we have, we'll pick an appropriate kinematics equation and we'll go ahead and use the time that we found before, and we can find that he lands going vertically at negative 24.2 meters per second. So he's going 5 meters per second in the x direction and 24.2 meters per second in the y direction. But I don't want two answers. I want one answer. I want to know the speed Batman's going when he hits his seat. So I'm going to have to go to the math of triangles. I'm going to have to consider that I have the x velocity and the y velocity with which he lands. Now I can't just add these two numbers together because they don't point in the same direction. So I'm going to have to create a right triangle where the actual landing speed is the hypotenuse, and the two pieces of the speed, the x and the y, are the sides of my right triangle. And I can use the Pythagorean theorem then to combine the two sides together and find the overall velocity. And I find that Batman lands at 24.7 meters per second, which is just about 55 miles per hour. So things may not go so well for old Batman in this case.